Alright, in this section we're going to be adding and subtracting the polynomials. So let's go ahead and get started. When we're adding and subtracting polynomials, we again are only going to be able to ever add things that are like terms. So let's just start with this polynomial and simplifying it. So my like terms are anything with the same variable and the same exponent. If they don't have the same variable with the same exponent, they are not considered like. So I've got 15 plus 2, which is 17m cubed, and then this stands alone, so it's 6m squared. The next one, we're also going to make sure that we're writing these in standard form, so I'm going to find the things with the highest degree and add those together first. So I've got 3 and negative 7, that makes negative 4x squared. Notice I'm not changing my term afterwards, it stays the same. And then I have 5 plus 12, which is 17. So I have negative 4x plus 17. And this next one, I've got to look for things that have the same variable with the same exponent. So if you will look here, this has a b cubed c squared. This also has a b cubed c squared, and this has a b cubed c squared. So these actually can all be added together. And what that will do is create what we would call a monomial, a single term. So 9 plus 5 is 14 plus negative 13 is just a 1. 1 b cubed c squared. Now the 1 is unnecessary, so we really would just write b cubed c squared. This is the way a lot of our problems are going to look, and they're going to look like we're going to add polynomials together. Being more specific in this would be a binomial that has 2 terms plus a binomial that has 2 terms. What is really going on here is there's a 1 that sits in front of each of these parentheses. The 1s, when you distribute, does not change the problem inside. So if I distribute a 1 here as well, I get an 8m squared and a 5. When I add my like terms, I get 20m squared, and then I have 4 plus 5, which is 9. The next problem, again, I'm adding like terms. So again, there's those ones there. I'm not going to show you that. We know that the 1 is not going to change anything. So really, the parentheses are unnecessary. So when I add my like terms together, I have 1 plus 3, which is 4t squared. And then I have negative 6 plus 11, which is 5. So I end up with 4t squared plus 5. My next problem, I have addition again, so the parentheses do not matter. So I can just go ahead and rewrite this without any parentheses, and then add my like terms. I've got 9 and 7, those are both w cubes. That gives me 16w cubed, plus, there's only a w squared, 8w squared, and then I'll put plus 4. And my next one, this is my last sum problem. So I will again replace or just rewrite everything without the parentheses because it's like I'm distributing a 1 through. And I'm distributing a 1 through again. So I end up with exactly what's inside the parentheses. So 2p cubed plus 9p cubed is 11p cubed. Then I have 6p squared and 11p squared, which would be 17p squared. And the last one, 10p and 3p, gives me 13p. On the next video, I will show you how to simplify differences.